Alrighty, my friends, we're going to show that the vaporization or boiling of water is spontaneous, so it occurs at no additional energy, just kind of on its own, at 110 degrees Celsius and 1 bar. And there's a variety of different ways to show that a phase change is spontaneous. I have some other ways in the description below, but in this video, we're going to use the fundamental equation of chemical thermodynamics. The change in Gibbs energy G is equal to the change in enthalpy H minus the temperature times the change in entropy S. Temperature is constant, which is fine because we're boiling at 110 degrees Celsius. Now we're going to make another assumption, and we're going to assume that the change in enthalpy and the change in entropy are constant. So what that means is that it doesn't matter what temperature we boil this water at, the change in enthalpy is not going to change. So this is the standard enthalpy of vaporization, and this would be at 100 degrees Celsius, 40.7. So it'll still be 40.7 kilojoules per mole, regardless of the temperature in which we boil it at. Now, it's not constant, but over small temperature ranges, we approximate it to be. So we're going to use this assumption and add some notation in here. This is the change in vaporization of Gibbs energy at 110 degrees Celsius, and this is occurring in its standard state, so a constant pressure of 1 bar, and we're assuming it's pure water, which is equal to the change in enthalpy minus the temperature, which is 110 degrees Celsius in Kelvin, times the change in entropy. Okay, so we've got to solve this equation here. And to get the change in entropy, we're going to look at 100 degrees Celsius, which is 373 Kelvin, and at 100 degrees Celsius, liquid and gas phases of water are in equilibrium. If they're in equilibrium, then the change in Gibbs energy is 0 at that temperature. And if we plug that into this equation right here, we get this right here, and we can solve for the change in entropy right here in terms of the enthalpy. And then we can plug this in to this equation right here. So now we have everything in terms of the change in enthalpy. We can plug in our numbers, and this is the temperature we want to boil it at, 110 degrees Celsius. Oh, I wanted to mention something, if just in case it's not clear. This is the change in Gibbs energy at 110 degrees Celsius, but here we have the change in enthalpy at 100 degrees Celsius, and we could do that. Same with the entropy. That's not a typo, because we're assuming that the enthalpy change is constant. So we can use the value at 100 degrees Celsius for 110 degrees Celsius for the change in Gibbs energy. Okay, hope that makes sense. All right, so if we plug this into the calculator, we get a change in Gibbs energy of negative 1.12 kilojoules per mole. Negative means that the process is spontaneous, and if it's spontaneous, then the change in entropy of the universe is greater than 0. We can solve for this change in entropy by using this equation here. This comes directly from the second law. I can derive this if you want me to, let me know, but we'll plug in our value for delta G. There's a positive here because this negative cancels out with this negative, which gives us a positive entropy change of the universe, and life is good. Okay, y'all, hang in there. Good luck. Thermo's not an easy subject, but the more problems you do, the better you'll get. I'll see you in the next video. Cheers.